So everything we've done so far has been a one variable data set, and we've dealt with what we call raw data. Raw data means I give you every data point. So I would give you, for example, here are the top, 30 finishes in the Peachtree Road Race. Here are all the data points, and you graphed them. What we're going to move today is in graphing things that instead of giving the raw data set, I've been given a summary, and it's just a different way of looking at it. So let's take a look at these are 100 students in Algebra 2. These are their scores on the data assessment test. Now, if this were real life and you had a job and you were analyzing data, this would be considered a very small data set. If you are sitting in my class taking a test, what is this considered? This is a large data set. It's large because what would you have to do with it? You'd have to punch every number in, okay? So that would be a good 15 minutes of the test. So like the homework, you rarely had more than 20 numbers to put in. So you'll never see something like this on a test, to have to enter in. Same thing on a SAT or PSAT. They're not going to give you 100 data elements to put in, but they're going to summarize them in a way. And that's what we'll talk about today, how these things might be summarized. So let's take a look. If I were to put all of that data in my calculator, what kind of plot is this? Dot plot. Okay. What does that tell you? I mean, if you look at it, if I look at the previous raw data here, I mean, do you get anything out of this? It's hard to get anything out of this. So that's why we want to look at this. So what do I see here? What does this tell me? How did people do on this test? Yeah, not good. I mean, you would not want this to be your class because in general, how many people made A's? I mean, you look at it, I only see like what, 4, 5, 6, 7, 8, maybe 9. 9 out of 100 is what percent? 9%. Okay, so not very good. So it looks like most of the people are bunched together in that, D to C range. So what do you think the average is going to be here? I think it's going to be a C. So it's probably going to be, something around, maybe a 74, 75, 73, somewhere in that area. Okay. So I'm not going to do that. But this is just an example of this one visualization, but this is still raw data. It's raw data because each of those dots represents what? One person's score. So this is just a graphic visualization of the raw data set. Now, what you're likely to see for data sets that are this large and even larger is not a raw data set, but you're likely to see something like this, which is a histogram. Histogram looks like what? A bar chart, okay? But I mean, it's just racy bars. But what have I done? So what is implicit in looking at this graph? What have I done with the raw data? Yeah, well, not forced, but I've grouped it in a certain way, okay? So what this tells me is I've grouped together, this looks like from everything from 50 up to almost 60. This looks like what? 60 to 70, 70 to 80, and then, this is what? 60. 60 to 70, 70 to 80, 80, 90, 90, 100, okay? And so what happens is if I made let me just go ahead and draw it. It'd probably be better to do this. This is 60, that's 70, that's 80, that's 90, and that's 100. So if I made a 70, which bucket do I fall in? The second bucket. So what happens with the histogram is this is a 60. Everything up to 70, but not including 70, is in this first bucket, or the first bar. 70 up to, but not including 80 is here. 80 to not including 90 is here. 90 not including 100 is the last category that you see here. So now I can start to see we thought this wasn't very good in terms of a test score. Most of the people made between what grades? Most people made C's, right? It's between 70 80 is where I saw most of the scores. About how many people did that? Let's see, this is 30, that's 45. So every one of these is 5. So that looks like maybe 52, 53 people. It looks like, so if you count this, this is 30, 35, 40, 45, 50, 55. So this is 50 right here. So it looks like a little bit more than 50 made C's on this particular test. Okay, so now let's look at that. I think it's going to ask us to figure out what do people make. About how many people made D's. Okay, let's just consider 60 to 70 D. So it looks like maybe like 29 or something. You know, it's just slightly below 30. So maybe about 29 made D's. C's, we say this is probably about, if 50 is right here on this mark, and that's 55, so maybe like 52. How many made B's? 5, 10. If 10 is right here, this looks a little bit more, maybe 11 or 12, something like that. Looks like how many made A's? Maybe this is 5, 10, looks like maybe 10, something like that. Pardon me? Right, if I did it exactly. I'm having to estimate here because I don't really have exact numbers. What does this add up to be? That's what 82 minus 1 is 81. This is not quite adding up. 91, 102. This is adding up to 102. So that's what I said about how many, okay? It was hard for you to get exact because, I mean, who's to say that that's not 28 or 29? You really can't do that. So that wasn't the point here. So just in a general rule, I could look and say, okay, this is about what this distribution is, okay? It's easier to work with this than to have those 100 numbers, put the 100 numbers in and get the real precise answers. You can glean information just by looking at the grouped data. So now you see the difference between raw data and grouped data. Raw data, you have every element. Grouped data, it's been grouped in a certain way. What was the thing we did yesterday or Wednesday that was the grouped data? What plot? Yeah, the box plot is grouped data. The dot plot is what? It's not grouped, it's what? Individual. It's raw data. So raw data was a dot plot, grouped data was a box plot, and now we have a histogram, which is grouped data. So now, there are things that we can get from, suppose you started with this. Now, if I had the raw data set and I ask you for the median, what would the median, how would I find the median on that raw data set of 100? What would I do? I got two choices. I can line them all up from smallest to largest and go count of 100 data elements. Where would the median be? It's going to be the average of 50 and 51. Okay. When you have an even data set, the median is the average of the middle two numbers. If you had an odd number, the median is going to be what? The numbers in the middle. Okay. So if I had 101 data elements, then the 51st data element is my median. If I had 100, it's the average of 50 and 51. So if I had the raw data set, that's how I'd find the median. But if I did not have the raw data set, how can I find the median here? Or where it's going to be? Is the median going to be a D, a C, a B, or an A? So how many data elements are there? 100. So we just said that the median is going to be where? The middle. So it's going to be of 100 data elements, which data elements are going to tell me the median out of 100? The average of number 50 and 51. Okay. So look at this. This first bar here, how many elements are here? 29. Okay. Do you think that I've reached the median yet? No. But then when I move over into the C's, then I've got, okay, somewhere that 50 and 51st number is here. So I know that the median has to be what? A C. So the median grade has to be a C on this test. Okay. So how do I know that? I know that the median is going to be the average of the 50 and 51st element. A histogram lines them up from smallest to largest. So I know that this has to happen. It has to happen in the C range. Okay. So I don't know what the median is, but I know it's a C. So this is what you can do with summary or group data. If I had the raw data, I could tell you the average is 76.2, or excuse me, the median might be 76. But here I know that the median has to be a C. Okay, so I can't get the precise number, but I can get the grouping part of it. Okay, so that's what we can do a little bit different with group data than we can with raw data. So what I'm going to do next, and you can follow along here, let's take this data set, much smaller than what you just saw, and let's just see if we can enter this data into a histogram. So you'll need to know how to create a histogram. I think it follows pretty easy. So where do I put the data in? What type of document? List and spreadsheet. And so this is going to be class size. So class size, and it has to be one word. Okay. And then no, it has to be one word, no spaces. And then I'm just going to enter these data. Now, remember, it's very important that it has to be a column. You don't, like, even though I've got it here, row and column, you don't go across. You have to put everything in a column lined up. It doesn't matter the order in which you put these numbers. And I just find it easier to type over here on a keyboard. You probably would too, but you've got a calculator. So let's go ahead and enter these in. 20, 15, 13, 12, 17, 18, 16. And after I enter this, what is a really good practice? Check those 20, 15, 13, 12, 17, 18, 16, 16, 14, 14, 15, 13, 19, 16, and 12. Okay, so the data is there. Histogram for this data set. So where do you think that will be? Oh, sorry. Escape. Where do you think I'll go for that? Data and statistics. Okay. And what data am I going to use? Class size. Okay. What did that create? Dot plot, but I want it to be histogram. What do you think I will do? Plot type. There you go. Histogram. Okay. So that is a histogram. Now, this histogram, it creates, so it's all the class sizes, but this is the classes of what, so it looks like this is going from what, 11.5 to 12.5. So what is the only number in that bucket? Between 11.5 and 12.5 in class size. These are people. 12, okay? We don't have a class size of 11.5 people or 12.5 people. Same thing here. So each of these is what? Individual class sizes, okay? So has the data been grouped in any way? No, I mean, this is just each of these, this is like classes of 12, 13, 14, 15. Can you see? So when I look at this, you know, it doesn't really tell me much. I'm really looking at the raw data. So what we want to do here is plot properties, okay? So under plot properties, I want to change certain properties of the histogram. Where do you think I will go? How about histogram properties, okay? And then the length of those bars is it's a bin setting. So I'm going to change the equal bin width. Right now the width is 1. That means I'm only looking at class sizes of 1. Did I specify what I'd like you to change it to here? Let's change it to bin width of 3. So if I change that to a 3, then we go back and we see the plot looks like this. Now, what's sort of different about this? Does that really look good or visual, or what's bad about this? Oh, yeah, it's sort of chopped off at the top. So we'll go to menu, window, and let's just say zoom, so it refreshes based on the data. Now, so this is a better visualization for me. So let me pause for a second, make sure group the class sizes. So it tells me that, what do you think is the most commonly occurring class size that we see? Well, not 15. So this is every number between 14, 15, 16. When you get to 17, you're over here. So 14, 15, 16, okay, that appears to be the most common class size. What's the least common? Yeah, 20, 21, 22, 23. Okay, so that appears to be. So anything from 20 to 23 appears to be the least common, which is what you want. Mm-hmm.
If 23 is touching, like on that line, you just count that?
Well, technically, it's 23 is not included here, so I would probably take 20. Well, it's sort of different here because if this was temperature, so first of all, these are people. So really, it doesn't make sense to say the class size goes from 20 to 20.9 because we really try to count only whole people. Okay, so in something like this, I would be a little bit lenient on that. But if it was temperature, it's everything between, if that was temperature, everything between 20 and 23. It's understood once you get to 23, you move into the next bin. Okay, so what are some of the questions that we ask on this particular one? So you've got the instructions there for taking that dot, creating the histogram, and then changing the bin size, which is what you see. So again, it looks like we have more classes in the range of, you could just write, the range of 14 to 17. That's the range of values. The numbers that show up in there are 14, 15, and 16, okay? So the median class size, where do you think the median class size is going to be? Okay, so first of all, how would you need to find that? How many data points were there? There were what, 15? Okay, so if I've got 15 data points, so just make sure that you know this. If I had 15 data points, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So how do I know the median? So it's the exact middle, so it's going to be, that is the median of my data set. What number is that? Yeah, so it's 1, 2, 3, 4, 5, 6, 7, number 8, okay? Because I would have 7, 7, and then 1 in the middle. So the eighth data element is going to be my median. So where's the median going to show up? Right, so how many elements are in this first bin? 4. How many are here? 7. So that's 11. So by the time I get there, somewhere in that bin is my median. So I know that the median has to be between what? Yeah. So it has to be between 14 and 17. So somewhere in that range is the median of my data set. Okay, so you okay? I didn't know it made phone calls. Okay, so that's a different question. So yesterday, if I ask you for the median, you would put the numbers in, you would do this like you would count, you would find the exact number, you would do a box plot, one data statistics, many different ways. If you do not have the raw data and you start with a histogram, you can still find where the median is. So I could ask you on a test, is it possible that the median of this class size is 18? And you can say, no, that is not possible. When you look at this histogram, you don't know what the median is, but you know it has to be right here in that second bin. Okay? Now, what about the median? So if I gave you all of these numbers, it wouldn't be too hard to find the median, or you've got your calculator, the statistic, what would you do? If I gave you all these numbers, the raw data, how would you find the mean? You can either add them all up and divide by 15, or you've got that one variable statistics, it spits out, X bar, which is the mean. What if you don't have that? What if you have group data? What can we infer about the mean? Okay, so we're getting close. Will I be able to come out and tell you that the mean is, 15.2? No, because I don't have the raw data, so I can't add everything up and divide by 15. But if I were to tell you that, is it possible that the mean is 30? What do you know? That's not going to happen. Why? What if I were to say the mean is 12? Do you believe that? No, you don't quite get the feel. You get the feel it's somewhere between 14 and 17 or something. But how do we guarantee that? So if I look at this, what is the smallest number that can show up here? 11, okay? Okay, what is the biggest number in this bin? 13, okay? What's the smallest number here? 14. And what, 16? And then we've got 17 and 19, 20, 23. How can I use that to figure out what the mean might be? What is the smallest, how can I figure out what is the smallest number that the mean can be? How can I figure that? Right, I could pretend that all the four numbers in here are 11, okay? All seven numbers in here are what? 14. All of the, what are these, three numbers here are 17, and the one number there is 20. If I pretended like that was the case, that would give me the what? The smallest value that the what? That the mean could be, okay? So let's figure that out. So what is the smallest value of the mean? So let's just figure out the smallest. The smallest value that the mean can be is going to be 11 times 4 plus, what was the other one? 14 times 7 plus 17 times 3 plus 20 times 1 divided by what? 15. Why 15? 11, 12, 13, 14. There are 15 numbers here, okay? So that is the smallest that the mean could be, okay? Do you want to do this by hand? I would probably say no. I would get myself a calculator page and just figure out what was that. It was what, 4? What was the first number? 11 times 4? 11 times 4 plus what? 14 times 7 plus, what was it, 16? 17 times, what number? 3 plus 20 times 1. All of that divided by 15. And if it gives you that, let's just go ahead and you can always do Control Enter and get a decimal. So what is that, 14.2? So what does that tell me? That is the smallest number that the mean can be, okay? So this is 14.2, okay? Now, what could I also do? Now I've got this. What could I do on the other side of each of those bins? The largest value that the mean can be. So the largest that the mean can be is going to be, it's going to be what, 13 times 4 plus, what's the other number? 16 times 7 plus 19 times 3 plus 23 times 3, times 1. All of that divided by 15. Okay. Now, I could do that in my calculator, or I could be smart about it. What's the only difference between this line and this line? Every number went up by what? 2. I could punch in the math here, but somebody take a wild guess of what that's going to be. 16.2. Okay. So you can do the math here, but it makes sense. So like if the smallest number is 14.2 and then I move everything up by 2, the largest value of the mean is 16.2. So which of these numbers would be acceptable to be the mean? Any other number? Yeah. Those are the only two numbers that I see between 14.2 and 16.2, right? So on this list of numbers, on the choices I gave you, those are the choices. So like on an SAT test, the mean might actually be 15.5, but I'm saying of the numbers I just gave you, which ones of those are possible? You know, it's not possible to be A or D, okay? The only possible answer there would be B or C, okay? Because I found the mean has to be between 14.2 and 16.2, okay? So that's the kind of data you can, it's individual data coming from a group piece of information, okay? So where are we to get into politics? So let's just look at the data, okay? This talks about popular vote. for President Trump in the 2016 election. Okay, so this is another thing, a skill that you're going to need on the PSAT or SAT, is to look at chart data like this and to be able to answer certain questions. Okay, so this says the percentage share of votes among gender and race groups. Okay, so it says among white males, 62% of those voted for President Trump in 2016. White females, 47% voted for him. Now, what this chart does, a lot of them, when you see on the SAT, are going to total these things out, but you see that 62 and 47 don't add to 54, okay? So this one doesn't total up. But what this says is, of the white vote, 54% of whites voted for Trump. Of the blacks, what percent voted for Trump overall? 6%. Okay, you got that. So how does this happen? How is it possible that 60% of males voted for him, 47% females, but he only got 54% of the white vote? Yeah, so there are different numbers of male or female. Okay, so it's not like these things weren't totaled up. Okay, so this is just, I've debated about putting this chart in just for that reason, but we did. So where was the worst support? I mean, it doesn't take a whole lot here. So it looks like which two demographics? I mean, they're both. It's either basically black male and black female. So those are two demographics in which his support was the worst. I mean, it doesn't take much to look at that. Okay. Now, among the white voters, can you tell were there more male or female? Why do you say that? Okay, a percentage, so think about it. But I mean, if you think about it, suppose this represents the males, and these first two voted for Trump. That would say he got 66%, okay, of the vote here, okay? Now, suppose this was the other group, and he got, 50%. He would get more votes here, right? So suppose, like I said, if two out of these three voted for Trump, that's 66% support over here. If half of you voted over here, I'm getting 7 votes. So you got more votes over here than you got over here. So let's figure out what is the average. What's the average of 62 and 47? So 62 plus 47 divided by 2 is 54, right? No, that's not right. If I average those together, this is what, 109 over 2, which is what? 54.5, right? It's what? Oh, not quite. If I add these together, 109 divided by 2 is 54.5, right? You guys have calculators, right? Okay, so 54.5. So what I'm saying, if I straight up average these things together, I get 54.5, okay? So that would mean if they were weighted equally, 54.5 is average. So if I look at it, which of these numbers is closer to 54.5? Okay, how far is this one? So 62 minus 54.5, are you guys doing this? So 62 minus 54.5, 7.5, and then what is 54.5 minus 47 is 7.5. Is that right? It's the same. Oh, sorry, it is for that. So sorry. What I want to look at is if I'm trying to determine if there are more. If it was a straight up average would give me 54.5%. But I'm getting 54% is the percentage that he got. So this is skewed closer to which of those numbers? So this 54, is it closer to the female number or the male number? Which one? Come on, guys. 54 is closer to the female. So what's happening is the female votes are weighting more in this. So where were there more, male or female votes? There were what? There were more female, okay? So there were more female, okay? So if I did a straight up average, I would get 54.5%, but I got 54%. 54 is closer to the female. So there were more females here weighting that average down, okay? So the average came down, like this number here was pulled down closer to the female range. So there were more female voters, okay? That's a pretty little tricky question there. Okay, but you might see things like that. Now let's look at some of the demographics of the election. So I've got white, black, Hispanic, male, female. Okay, according to this chart, black votes made up what percentage? How do I figure that out? Yeah, you just read it. Okay, this one is a chart that does totals across. So what you see here, this bottom row is a total, and the right column is a total. So the black vote made up 10% of the electorate, okay? Non-white females is what percent? So what does it mean to be non-white? That means you're what? Well, I know it's not white, but in this category, if you're not white, you are what? You're black or Hispanic. So black or Hispanic females make up what? Yeah, so yeah, black or white females is 6 plus 5. So that's 6 plus 5 is 11%. Okay. Non-whites make up what percentage here? 20%. Okay. So you'll see a lot of things on the PSAT that deal with charts like this. So you got it's can you read through this information and decipher what's in the chart? Non-whites, that means black or Hispanic. That's 10 plus 10. That is 20% of the electorate there. Okay, and let's look at this one. So now we've got another chart. We see age and we see percentage of users in that age that use Snapchat. Okay, so what is the projected increase in the total number of users from 2015 to 2021? Okay, these are the percentage of users. So the percentage increase. So how many people are using in 2015? 46.2%. How many are using in 2021? 89.2%. Now, to find the increase, what do I do? The increase is going to be what? 89.2 minus 46.2. So that's 43. But what did they ask for? What did they ask for? What's the question asking for? The projected, what's that next word? Percentage increase, okay? So I'm saying if I start here, when I get to 89.2%, by what percentage have I increased? Okay? So if this were on an SAT, 43 is a number that is sitting there waiting to be chosen by you, but that's not the percentage increase. How do I find the percentage? I got to figure out that 43 is what percent of what? Of 46.2. So I got to type this correctly. So 43 is what percent of 46.2? How do I figure that out? This is called middle school math, guys. What you can do in math is means equal. So 43 equal blank percent. Odd means times. Okay. Okay. So I got to do what? Divide. Yeah, divide 43 by 46.2. And what number are you getting? Yeah, it's a 93.07%. So here's where it increased by 43, but the percentage increase was 93.07%. Okay, so that's the thing. We're not going to spend a lot of time on percentage. We assume that is there, so you need to sort of brush up on what that means, the percentage of increase. Okay. If I were going from, what about if I went from here to here and I was looking percentage of decrease? If I was saying, what's the percentage decrease from 2021 to 2015? I would look and say that 43 is what percent of the 89.2, okay? Which age group shows the greatest percentage gain from 2015 to 2021? I mean, can you just look at it and tell, or you? I mean, here's what I got to do. Like, so I can just look and say, okay, what multiplier of this number gives me that number? Okay. So what is 2 divided by 0.6? So this is what, 3.3x. Okay. 16.3 divided by 11.3. That's 1.4. 23.8 divided by 16.6. That's 1.4. 24.4. And you can start saying, I mean, you could even round. I mean, like 24 divided by 11. That's going to give me about 2.1. I'm looking for easy numbers here. 9.8 divided by 3.7 is 2.6. 6.7 divided by 1.7. That's 3.9. That's the current winner, right? 4 divided by 0.7 is 5.7. That's now the current winner. 2.2 divided by 2, that's probably going to take it. That is 11. And there we go. So what happens is I started out with 0.2% of our geriatrics using Snapchat in 2015. I ended with 2.2%, okay? It's not the largest demographic, but it's the largest what? Percentage increase, okay? So they've gone up by a factor of 11. So what age group? That would be the 65 plus, okay? Now, which age group is using Snapchat the most? Right now, let's see, what year are we in? 2019? Who's the biggest user in 2019? 18 to 24, right? So is that the biggest number? Right there, okay? So I don't know. I mean, this was data that I pulled. Okay, let me just pause for a second. I mean, I don't know. What is the median age for a user in 2015? The median age for a user in 2015. So what's the median of a data set? The middle, okay? So how many users, okay? If I look at it, so if I look at this, what percentage of the population overall is using Snapchat in 2015? What percent? Overall, 46.2, okay? So if I was going to try to find the middle, okay, from an age standpoint, if I got 46.2, what's half of 46.2? 23.1. So I would need to go, if I add 0.6 and 11.3, I get 11.9. If I add 16 to 11, I get what? 27. So where is the median going to happen? It's going to happen in here. That's where I'm going to reach the median. Does everyone see how I did that? Okay, so there are a total of 46.2% using, okay? So if I look at that, the median age is going to happen when I reach the 23.2%, 23.1. So that happens when I get to the 18 to 24 range. So I know that the median user has to be 18 to 24. That sounds pretty accurate, okay? So that's a popular use group. So, but it's saying half the people that use it are less than that, and then half using above. So what does that mean? If the median is 18 to 24, what does it mean about old people like me? They're not using as much as the people who are younger. I mean, because if you look at it, it's all grouped together. The people that are younger than using, I doubt that people younger than 12 are using this. But you look at it, 24 to 70 or 80, that goes a lot higher. Okay. Now, what is the projected median in 2021? See if you can figure out what do you think the median is going to be in 2021, according to this. And I projected the average user would be 25 to 34. Okay. What does that mean? So 2 years from now. Either people older started using, or what happened? People who are using it are still using it. They aged. Okay, so so what would happen is, okay, you're 24 now, and you're in the prime demographic at 24. 2 years from now, that demographic moves up. Okay, so just studying a little bit of the trending. Now, what about the mean? How could I find the range of values for the mean in what year? 2019. So what's the lowest and highest value? So in 2019, I'm looking for the average. So I've got data grouped together. Can I figure out the mean? No. I can't figure it out. The data is grouped, but I could get a range or an estimate. So if I'm trying to estimate the mean, I'm going to look for its what value and its what value. Its lowest and its highest. How could I figure out the lowest value for the mean? Yeah, I could say, let's pretend that we had 0-year-olds using this. Okay. And I'm going to leave this for you guys. This is what we did a moment ago. You're going to do 0 times 1.7, 12 times 15.9, 18 times this. You're going to get an average there, okay? And then you're going to say, take these other numbers over here. But what happens to this 65 plus? So 65 is the smallest it gets, but what's the upper end of that 65 plus? Okay, how many 100-year-olds do you think are using Snapchat? Probably not. So here, probably make an assumption, okay? So just why don't you make an assumption that nobody over 80 is using Snapchat? So this is a case where you have to make an assumption. Okay, you guys can figure this part out, and I will see you on Monday.